Big rig engineers must constantly walk the line between heavy-duty toughness and cost-effective fuel efficiency. They've found the perfect balance in the material for the hood. It's extremely strong and resistant to dings and damage, yet it's extremely lightweight, and it easily molds into a streamlined aerodynamic shape. Hard to believe this critical ingredient comes from tiny ancient marine organisms. It's petroleum-based plastic. 300 million years ago, and dead organic material, like algae and even dinosaurs, is collecting on the bottom of oceans, riverbanks, and swamps. It's mixing with mud and sand, and more mud and sand.
Decomposing organic matter, buried deep in the earth and exposed to heat and pressure for long periods, turns into a dark, waxy substance that's rich in carbon and hydrogen, the building blocks for petroleum.
Millions of years later, in 1907, Dr. Leo Baekeland is looking for a new way to insulate electrical cables. He mixes a chemical derived from ancient petroleum called phenol with formaldehyde. The liquids react and become a hard yet moldable substance he calls Bakelite.
Bakelite is the first in a long line of petroleum-based plastics. Plastics begin with special molecules called monomers that link together into long chains called polymers.
Bakelite is the world's first synthetic polymer plastic, but it won't be the last. On its own, Bakelite's naturally brittle. To make it more resistant to cracking, it needs to be mixed with a filler, like sawdust, and this gives it an unattractive, dark, dull color. Fortunately, this is just the beginning. This new, versatile polymer science ultimately opens the door for thousands of unique combinations and techniques.
When creating polymers, you can make them long or you can keep them short. You can give them multiple arms. The sky's the limit. This type of versatility is what allows plastics to have such a wide range of physical characteristics.
Today, chemists have refined Baekeland's idea, creating plastic polymers for every application imaginable. From smartphones to the space shuttle to the flexible, injectable plastic for the Mack truck hood. At Paramount Manufacturing in Abingdon, Virginia, engineers use plastic polymers to create the lightweight yet strong hood of this superhighway truck.
With diesel fuel being over $4 a gallon, every 1/10 of a gallon you can save is huge dollars. The lighter the weight you can make that product and still maintain durability, the better it is for the customer.
The manufacturing process has 3 steps: material testing, molding, and finishing. In testing, a technician pre-mixes samples of the 2 chemical polymers that react to form solid plastic. Checking the mix on a small scale now allows the team to verify the components are free of impurities before molding the hood. If there are impurities in the mixture, the polymer turns into the consistency of wet asphalt. If the batch is pure, the polymer hardens into a solid block that would make Leo Baekeland proud. After about 1 minute of stirring, the liquid begins to harden.
Curing occurs by the chemical reaction of 2 components, a resin and a hardener. When these are mixed, the polymers begin bonding, linking together in an exothermic reaction that releases a lot of heat. At its peak, it can be over 500 degrees Fahrenheit.
As the reaction begins to achieve completion, you see smoke start to come off of the cup.
This sample is rock solid, confirming the mixture is free of impurities and ready for production. The next step is molding. To form the hood, engineers use large shapes that come together like a clamshell.
Okay, as you can see, this would be the shape of the hood, and this would actually be the top of it. And here, if you would look, the customer would see this would be the wheel opening, and the wheel actually will go right underneath here. This would be actually like the fender for the hood, so it's all one component. The material will flow up here and actually will spread out evenly, and it will flow through this runner, this gate, and actually evenly fill up at the same time all the way up into the mold.
Operators close the mold and inject the petroleum-based resin and hardener. As they mix inside, it's critical to avoid air pockets. One small bubble can ruin the entire part.
If you get air in there, it basically will stay as a liquid and it will not cure, will not harden at all.
To combat this, jets inject the two chemical components from the bottom up. This way, as the mixture rises, air escapes through the top instead of becoming trapped inside.
This works because of the nature of curing polymers. Curing takes time, and this allows the air bubbles to move up before the liquid turns into a hardened polymer structure.
The components combine, harden, and form the hood in under 2 minutes. Less time than it takes to fill up a tank of diesel. Once the plastic completely sets, operators open the mold and reveal the new hood. A smooth, perfectly hardened surface. The final stage is finishing. A robot glues small brackets and braces to the hood using industrial-strength epoxy. And then workers sand down the rough edges. The all-plastic hood is complete, an aerodynamic structural element made strong and light. All thanks to Earth's powerful brew, petroleum.